Okay, so type 3 is probably the most common, and even in grade 12, you're going to see a story type of scenario. Probably the most popular in grade 12, where you get a story and you need to kind of like decipher what's happening here and how do I come up with my points, right? They have to give you enough to get you started. So on last lesson, right, we just figured out, okay, there are scenarios where I given the start and the vertex, I have to find the third point using symmetry. So it could be that I'm starting on the ground, I'll be back there in twice the time, right? If it takes me 1.25 to get to the center, it would be another 1.25 to get to the other end. So just multiply the x value of the vertex and voila, right? You could also be starting somewhere above the ground. Remember, you're going to come back to it. A lot of students get that third point down here. So they go 7, 0. They put 7, 0 here. So it's like you're kind of getting there. You multiply that times 2, but you shouldn't be down here because you're not starting there, right? So that's, and then that's flag number 1. If you miss this, if A says, hey, find how long this thing was in the air, they give you a full mark for it, and you just have to say, well, 7, 0, right? Something isn't right. You got to go back, say, oh yeah, I get it. I probably should have picked this point here, and then now that I'm being asked to find how long it was in the air, I'm going to have to do some calculating there. So keep that in mind. Then you also had the scenario where you have 2 points that are across each other, but you somehow have to find the x value of the vertex, right? So that would involve dividing by 2, right? So if you have 2 points across each other, divide it by 2 to get the x value of the vertex. So that's kind of what we explored last lesson. So today we're actually going to put this into practice, right? We're actually going to put this down on paper and see what it would look like. So page 72. Roger would like to recycle his beverage container. He throws his container up from a height of 175 meters and estimates that it reaches a maximum height of 2.8 meters after 0.75 seconds. I don't know about you, but to me, this should stick out here. This part should stick out. That is definitely the vertex and not just the maximum height. Is like both components that make up the vertex, the time and the height. So, okay, I know my vertex, right? And it's the container is being thrown up from a height of 1.75 meters. This is what we would call initial height. And we're definitely not on the ground. We're above the ground there. So some notes there. The container lands on the rim of the recycling bin. And we're told that the bin is 0.65 meters tall. So what do we do with this? Okay. I would always, so this is saying you will usually be asked to figure out the quadratic, determine the quadratic equation that models the path of the container. I will strongly suggest to you to make a sketch, not a graph. This is just a sketch, not drawn to scale at all, where we have time and we have height. Right? And so we're told that Roger is right at a height of 1.75, I should say. So we actually know that at time 0, we're at 1.75. Okay, so that is 1 point for sure. And the maximum height is a little higher, so we know that it's going up. And where does it land? It lands on the rim of the can. So the can is standing right here. And you know what I pictured here? You know these blue bins where you recycle, right? They have like a pretty big rim on it, right? So the can could land there, so it didn't get it into the bin, so to speak, right? So we know the vertex, and the vertex is 0.75, 2.8. make sure you get the order right, time, then height. Okay, so read carefully. A lot of students mix those up, right? And you know what? I put that 0.65 in there on purpose to throw you off a little bit. Because yes, we know that this point right here, we don't know how long it will take to get there, but we know the height, right? 0.65 meters. And I kind of wanted you to think, oh, that's my third point there. I wanted you to kind of go for it, but I'm giving it away here, right? Don't focus on that so much. Focus on this. You have a point and then the vertex. You're going to focus on this point and which one? The one that's going to be across from it. This one right here. Make a big dot there. That's the one we're going to focus on. I'm going to kind of have a line coming out of it so that it's not too busy there. What do I know about that height? What is it going to be? 1.75, right? You're with me? Monday morning, right? I don't want to talk. Just leave me alone, right? 1.75. Yes. And this is the crucial point right here. If it takes me, right, like again, axis of symmetry is key here, right? If it takes me 0.75 to get to the middle, it will take another 0.75 to get to the point across from the starting point. So I'm just going to go arrow and just going to multiply that by 2, right? I don't really care how you show that, right? But that would end up being 1.5, right? 1.50 if you like. Those are the 3 points I want you to focus on. This one, you cannot find the time just yet, right? You don't have the starting here. It would technically be a negative time, right, if you could, but you don't. You don't. So don't worry about this one. Can't find, right? Can't determine time yet. Okay? You cannot determine the time for this one yet, but we will get there. So at this point, I would like you to make your T-chart and just put in what you know. 0, 1.75, 0.75, 2.8, and then 1.5, 1.75. And I am going to highlight this because with the story type, that is a very common theme, that you have two y values that are the same because, right, we're using the symmetry, and you should see, oh, it's the same increment, right? 0.75, 0.75, right? So there's a pattern there. I'm using symmetry. We put that into L1, L2. And now we can actually answer this, stat calc quadrec. So usually you get 2 marks for coming up with the quadratic equation here. You basically get 1 mark for somehow showing me how you found the third point, and you get another mark for actually coming up with a quadratic equation. So let's do that. So we got to go stat edit. And the nice thing is we don't have the 3 columns like we've had so far, right? We just have the 2 columns. So it's take a second to double check. And now you can run your regression. regression, second 1, comma, second 2, comma, vars. Oh no, don't mind my way of getting the y1, just keep doing the shortcut that I showed you. But it should look like this when you're done. Run it, write down your equation. Negative 1.87x squared plus 2.8x plus 1.75. The 1.75 is actually a good indicator that you're doing things right. It's the y-intercept right there, which is clearly the case. Right? So there you go. Now I can ask anything I want because now you basically have your equation ready to go. And it's probably a good idea to now actually picture it, like find a good window for yourselves. And the story type is the best one to use Zoom 9 with. It's going to be pretty close to what you want to see. Zoom 9 is not going to work unless plot 1 is turned on. So you got to have that turned on. I'm going to go Zoom 9. And there you go. You've got your 3 points, but you're not seeing your x-axis, right? I don't know if you noticed that. So Zoom 9 isn't going to solve your problems, but it's going to help you. So I'm going to go to y-min and just go -1 in this case because the numbers are pretty small. I don't want to see too much into the negatives, right? So just y-min -1, hit graph. It's pretty good, but I still need to see a little bit more here, so I need to increase my x max. I'm going to go 3.5 or something like 4 would do as well. There we go. That's all you need to see there. So we're not interested in the negative x-intercept, right? We're not in this case. We're just interested in the positive quadrant here. We now can probably figure out how long it takes to land on the rim of that bin, right? Now that we have the quadratic equation, we can. So let's go ahead and find, what does it ask? How long does it take for the beverage container to reach the rim of the recycling bin? So how are we going to answer this? We know the y value. We want to know the x value. Okay? y2 is equal to 0.65. Then we're going to go second, trace intersect. I find the intersection of that. So I'm going to go y equals. I'm going to go to the y2 and change that to 0.65. Hit graph. So I know that the height is right there. I just want to know the x value now, which is going to give me the time. Enter, enter, enter. You get 1.82, 0.65. You're not going to subtract or do anything with it. You just want to know the value, right? It takes 1.82 seconds. So if you just give me that point, you wouldn't be getting full marks, right? You still need to answer the actual question, which says that it takes 1.82 seconds. So it being given to you at the very beginning was just to kind of, yeah, it was trying to get you to see, oh, well, maybe it's 1.5, 0.65. No. This one was just there just to kind of try to test you a little bit, right? How long does the container remain below 2.5 meters? Below, watch that, right? So we're going to go y2 is equal to 2.5. And we're going to go second, trace, intersect again, but this is going to be a little different. Let's graph it first. The 2.5 line, I mean, right? 2.5. So there are two instances. Okay, so I'm going to actually sketch this out. For us, our story starts at 1.75 goes up and then lands on the rim. Okay, so it's just a sketch. So the 2.5 line is right about here. So it should be obvious to you that I need to find both of these. Right? It should be. This would be time 1 and this would be time 2. Okay? So let's go ahead and find those and then see what we do with them. Second trace 5. I'm going to find the second one because it's closer. And remember, we're going to use these numbers to find our answer. So use 4 decimals. It's hard to see, but you get 1.1509. Okay. 1.1509 there. And time 1 is 0.3491. Okay, those are my 2 times there. Make sure you understand what's happening there. If I subtract them, which is called delta time, right? The difference, you go 1.1509 minus 0.3491. Let's subtract them. Click, 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 right? I'm gonna write everything down so far. What does this tell me when you find the difference in this case? What are you finding? Above, right? You're finding the little tip. You're finding this number actually finds the time. This, was it a can? Yeah, I think a can. It's spent above. So time spent above. I'm going to put this in brackets. Time spent above. We would actually say it's at or above. We don't want that. If you look at the story, we want the time spent below, right? So why would I do that to you? I'm actually doing that to throw everything that you can see in these scenarios at you, right? So time below, I'm just going to call it T below, okay? Make it a little. Time below would be what? The total travel time in our story is what? 1.82, right? I just figured it out. Usually that's how these questions go. Everything is kind of connected. I'm asking you to just follow and see if you understand what's happening. So minus 0.8018. So I'm just going to subtract the time above from the total travel time, and so that'll give me below. Okay. And that gives you, somewhere in my key here, 1.02 seconds. It's 1.0182, but now you can round, right? So this is what you were after. I'm going to use a different highlighter. Let's draw our trash can here, or our recycling bin. Okay. Is there an alternative, Mr. Gregson? Is there another way of doing this? Yes, but it's actually more work. It would be go this minus this, like this time minus that time, and then subtract this time minus that time to find these little chunks, and then you have to add them up. For me, this This is probably a little less work, and you get both answers out of it if you're just careful what you're doing with the numbers, right? You get the time above, you can also get the time below. Let's graph this, state the domain and range, and then I'll just ask you to try a few questions because I will AC you on this tomorrow because we need to make sure we know how to do these, right? So graph this scenario. Let's do our labeling, time and seconds. Height in meters, right? Yeah, you have a grid, so it should be nice. The graph should be very nice here. So we know that time-wise, we need to allow for 1.82, right? So you have lots of room, guys. So just go 0.5, 1, 1.5, 2, right? Spread it out a little bit. And then for height, I go up to 2.8. So I'm going to go half, 1, 1.5, 2, 2.5, 3, right? So you got lots of space, use it. So we're starting at 1.75, which would be right here. After 0.75 seconds, which is right here, I'm at a height of 2.8. 2.75 would be right there. 2.8 is just above it. And then 1.82, this is 17282 is right here. I'm at a height of 0.65, which is right about there. In this case, if it hadn't indicated that it lands on the rim, if it says hits the ground or anything, obviously you need to make sure this hits the ground, right? But we're told that it hits the rim, it stops there. For us, the action stops there. So the domain and range is just time, right? What is my time? I'm starting at time 0, and this action ends, in this case, after 1.82 seconds. For the range, the lowest I possibly get in this scenario is the rim, 0.65. The highest I possibly get to is given to me by the vertex, that's 2.8. So there you have it. Get rid of these pages down here, okay? Those pages no longer work because I put everything in one booklet, so you don't have to worry about finding them somewhere else in a different booklet. Right? I used to have 2. So I would just say the pages that follow, okay? Let me just quickly glance here, 73, 74 to 76. So 73 to 76, I would say do at least 2. Do at least, do at least 2 questions. Each page is one full question, right? There's one that I mix in there, type 0. If you're comfortable with type 0, you don't have to do that one. It's basically where I just give you all the points. That's it for the lesson.